Okay, hi, I'm Chris Lambacher, and I deploy Python-based web applications to Windows servers. We currently run 31 Python-based web applications running on one Windows Server 2003 R2 machine. The audience of these sites is primarily Canadian, and in October we had 648,000 unique visitors and 3.5 million page views. Okay, why? The Python web community is not exactly known for its Windows love, and many may be wondering why someone would choose to deploy to Windows. It seems like some people attribute the decision to a desire for pain, and sometimes it feels like you're the only one who uses or deploys to Windows, but rest assured, there are lots of us. Maybe your IT department won't let you deploy to Linux, even though you know they have a Red Hat box stashed in the back somewhere. In my case, I do some work for a non-profit who received some grant funding in 2010 to convert their large classic ASP application into something more sustainable. Unfortunately, in the 2 years between the original grant application and when the grant was approved, the application got to be too big for us to port all in one go. Luckily, we discovered ways to do this more slowly. Part of the application is now fully ported into Pyramid, but there's still a large body of code in classic ASP. We have a common Python library used between the classic ASP and Pyramid-based parts of the application that handles various kinds of shared functionality like security and overall page layout. You might think this is obvious, but before you start on deployment, you actually need an application. A surprising number of people venture into the Pyramid IRC channel and ask about deployment specifics before they've written a line of code. It must be because deployment is just so darn fun. Part of the motivation for putting your deployment cart in front of your horse application may be concern about what is and is not possible. So I will put your fears to rest, or maybe not to rest. Windows deployment is possible. There are two main strategies for deploying these applications. You can either be embedded in the web server or use a reverse proxy. Embedded in the web server is the PHP type model where your application runs as part of a big web server like Apache. The reverse proxy strategy is where Apache generates a new HTTP request to your dynamic application for your dynamic URLs. If you have a low traffic intranet site, you may be able to get away with just exposing your development server to the web, but this is not really recommended. Okay, there are two kinds of web servers for us to discuss. The first is a front-end web server like Apache or IIS. The second is what I'll call a WSGI server for lack of a better name, even though I know that conflicts with WSGI terminology. A WSGI server in this case will let you run your application and accept reverse proxied requests. These are similar to, and in some cases may actually be, your development server. Apache and IIS are the big fish for front-end web servers on Windows, and although Nginx is popular on POSIX systems and there is an in-process port to Windows, it does not appear to be ready for prime time. You may have some constraints which dictate which of these you can pick. I used to recommend Apache because of the included bells and whistles, but in IIS 7 and later, things got significantly better on the IIS front. We're running Windows Server 2003 and only have IIS 6, so we run Apache up front and reverse proxy back to IIS and the Python applications. Here are a few examples of WSGI servers. Any of one of these might work for you in a reverse proxy deployment model. If your framework uses something different, that could work too. I hear there's a popular framework called Django or something like that. Paste used to be the default server for Pylons, Pyramid, and the TurboGears 2 frameworks, but doesn't have Python 3 support. Waitress is the development server that ships with Pyramid ever since Pyramid grew Python 3 support. CherryPy has a well-regarded server of this type. Twisted also has a good WSGI server, and many people don't know that Twisted can actually put requests back onto a thread pool, so it can operate exactly like any one of these other threaded servers. There are a number of other popular options out there in the space that are not Windows compatible. They use fork and signals to do the nice things that they do, and Windows doesn't support those things. I find this very unfortunate. I would really like to use them. They look really nifty, but we'll have to use something else. Okay, so embedded in server deployment. In some ways, embedded in server deployment is the easy way to do things, but no web server actually comes with Python and WSGI support built in. I think the big win for this model is process and communication management. This model may offer lower communication overhead because an HTTP connection does not need to be made back to another process unless you end up using fastCGI, in which case you're doing another form of inter-process communication, so arguments can be made either way about which is better. All right. ModWSGI is the tool to use in process with Apache with a few caveats. The biggest letdown is that daemon mode, the ability to run your Python application in an external process, isn't available on Windows. As I understand it, each site does have its own Python interpreter, so you won't have to fight another site for the GIL. Okay, ISAPI. ISAPI WSGI is based on the ISAPI support in Python 32 and is reasonably easy to configure. Pi is a Pi is supposed to be focused around speed, aren't we all? But I don't know that it is quite straightforward to configure. So IIS WSGI is pretty exciting and new, like 2 weeks new. It looks very promising. And if you happen to be running IIS 7 or later, it uses the IIS 7 built-in fastCGI support. So you can use an external process controlled by IIS, and we can now feel cool like the PHP kids. Okay, reverse proxies let you control the process in which your application is running. You can have multiple identical processes for load balancing. You can merge two separate code bases into one, maybe with multiple languages, or you can decide that you don't like the web server's request handling model and use something different like Twisted or Greenlands. Apache comes with everything you need to do a reverse proxy setup. Unfortunately, it can be a bit unwieldy to use. IIS, on the other hand, needs some help. If you're on IIS 7 or later, there are extensions from Microsoft that can be bent into a reverse proxy setup. If you're using an older version of IIS, or you just like the solution better, you can use the open source Iconix ISAPI rewrite filter, which also includes a reverse proxy despite the name. And Helicon Tech has a couple of for pay options. This list is in no way exhaustive. I'm sure there are other options if this doesn't appeal to you for whatever reason. Okay, Windows services. If you're working with a reverse proxy or you're running a naked development server, you want your application to start along with the server, so you're going to need a service. You can create your own services in Python with PyWin32. WSGI service is a convenient wrapper, or at least a starting point for that, if you happen to be using a paste deploy based application that you want to run in a Windows service. You can also wrap any command line application with server any or server start. Server Any is from the NT resource kit from Microsoft, and Server Start is much more powerful and allows you to have separate commands for the start and stop events. Okay, so now you have some tools to slay the Windows deployment dragons. What problems might arise? It seems like people who start on POSIX systems think that fork is the solution for all process problems. Please, if you are not using Windows and you are writing new tools, Python has subprocess to create new processes in a way that works cross-platform. I'd also like to see tools using multiprocessing, though I don't think that this is going to be a good solution for Windows until people start adopting Python 3, because there seems to be some problems with Python 2 and Windows and sharing sockets between processes. Another similar problem is signals. It really seems like Windows has them, but they are just there to fool you. There's only support for a couple of the signals, and they don't include all the ones that the POSIX applications want to use, like SIG user 1 and 2. Even the ones that are supposed to work don't quite work the same way they do on POSIX. Beware of these and use some other kind of notification mechanism. Okay. A lot of people have been beating the use pip drum lately for installing packages, and they're not wrong, except that they are. Because as soon as you need a C extension, you run into problems because pip only installs packages from source, and then you need a compiler. Many Python developers don't know anything about C and compilers and linkers. Trying to give them succinct instructions about getting these things installed on Windows in the right version for their particular installed version of Python is hard. And installing Visual Studio on a production box, that's kind of gross. Better stick to easy install. It will just work with the precompiled version that the package author provided you. It will even work with those Windows installer exe files. The other thing to look out for, hopefully, is the wheel package format. It's in the process of being standardized right now, and there is an experimental version of pip with support for it, so hopefully we'll start to see this in use really soon. So it may be tempting to try and install all of your Python-only packages with pip and use easy install just for those ones that you need to use a C extension for. But this is dangerous. If you install packages that share a namespace with the two different tools, you are going to run into import problems. Best not to mix them, no matter how tempting. But if you must, one trick is to try and force an import of the easy installed package first. That often makes things work. I've had success with that with Pyramid and its use of some of the Zope namespace libraries. If you're writing something to be installed by someone else, you might want to cut down on the dependencies they need to install by using py.exe. Py.exe can be finicky with eggs. That's what easy install installs. And you might have problems with entry points because they don't, because once they're in a py.exe, they're no longer eggs. I've had success by excluding things from the library.zip file that py.exe creates and shipping an egg directory for the main application. All right. VirtualEnv helps you to keep track of VirtualEnv helps to keep applications with different dependencies from stepping on each other's toes by creating virtual Python environments. You should be using them. They're even nicer to use with VirtualEnv wrapper, which provides a bunch of helpers for making, activating, deleting, and otherwise managing environments really easy. The original VirtualEnv wrapper is a bunch of bash scripts, so not very useful from Windows. However, luckily, there are a couple of ports, one to bat scripts and one to PowerShell. The other thing that's useful to know is that you can use activate this to enable a VirtualEnv from running code. Run it as early as you can after the process starts, for instance, when your Pi-132-based service first starts up, and make sure it runs before importing the rest of your application. Caching and sessions are often stored in memory-based key-value stores, most commonly memcached and Redis. You can get memcached installed when you install the community version of Couchbase, and it comes with a nice monitoring application. But I found that the memcached libraries that were compatible with Windows masked connection errors with a key not found result, which comes back as none. If you have a reasonably high amount of traffic, you want a connection pool, and Redis clients have connection pool built in, but there's no production-ready Redis port for Windows. In our case, after memcached became overwhelmed by our increasing traffic load, our solution was to put Redis in a Linux VM. After moving to Redis, we started getting errors that we tracked down to being a problem with operating too many connections to Redis too quickly. Windows by default has a low limit on the number of outgoing connections it can initiate, and our request rate plus the time wait delay meant that these ports were exhausted very quickly when attempting to connect to the memcached or Redis servers. We ended up staying with Redis since it came with a connection pool that limited the number of open connections to a reasonable level. And I'm going to give you a dirty little secret here. We run our Redis virtual machine on the web box, and the load is insignificant at only 1 or 2% CPU under heavy traffic. All right, questions. I'll also accept heckles. I will post these slides as they are up on whatschrisdoing.com. They're also checked into GitHub, so you can get the whole source for them there. There's a bunch of links in there that you may be interested in.
That was awesome, thanks. This is a potentially stupid question, but you went through a few slides where things just don't work in Windows the way you expect them to work in POSIX systems, like with signals and stuff like that.
Right.
How often do you pull down a library from PyPy or something and have it just not work because of problems like that? Do you ever experience that? Or?
It's not generally a problem until you get into things that are servers, because those are the things that are going to want to fork stuff. It happens. Generally, it's either some C extension that there's no ability, it doesn't work with Visual Studio or something, or basically it's server stuff. And I generally look ahead of time for that kind of stuff. In terms of actual libraries, like templating libraries and stuff like that, there's not usually any problem.
Have you ever tried to commit changes back to the community with like a change set that says, hey, this shit doesn't work in Windows, and have them respond?
So yeah, I have done that. I've had successfully put patches back to make things work better with Windows. The one thing that I was really hopeful that I was going to get to work was there's a web server called Spawning, and it looked like it was going to work because it was based on G-Event, which worked, and it was pretty easy to substitute in subprocess instead of fork. And then I ran into that problem that I was telling you about with the sharing sockets between two processes. I have some tests with multiprocessing, and basically it works on Python 3 and doesn't on Python 2, and we're on Python 2 still. So that was like, okay.
All right, it's time for a coffee break.